presentation. Today's webinar is sponsored by Unifire AB, a Swedish company, of which we're very fortunate to have Mattias here as the second generation of owner and driver of the inventive and insightful stuff that they're doing. They've been in the business since 1969, and you can see that they're a mature company and gaining traction across the world because of the quality that they deliver. I'm not going to steal any thunder from either of them because I don't want to impose on their presentation. But I'm Bob Ray, I'm your host today, and it's an absolute pleasure to host the Fire Middle East webinar that is sponsored by Unifire, and to welcome Mattias and Roger, both from Unifire, different elements of the organisation, to deliver a presentation to you today. Now, what we have is you'll have the chat box, and there's also a Q&A session. I ask you to respect the fact that I will bring the questions to their attention at the end of the presentation, because I don't want to break their flow, because otherwise we'll wind up running past the time allotted. At the end of the presentation, what I will do is I will go through the Q&A and the questions in the chat, and I will ask the questions on your behalf and let Roger and Mattias answer them. If you haven't got any questions, then I will sure have some of my own. Being an ex-firey, I know that I'm going to find something of real interest into this. And so I'm going to hand over to Mattias first to introduce himself, and then he'll hand over to Roger, and we'll get underway.
Thank you. Well, thank you to all of you for joining us here today. This is really exciting, especially when we don't know exactly who is on the other side of the camera this time. So that's a bit unusual. I should start by giving you just a little bit of a background. You might wonder what Unifire is, and you already heard something about it. But the company was founded about 55 years ago in the early 1970s. Making fire hose nozzles at the time. Back in 2001, so 25 years ago already, we produced or started building our own robotic nozzles, which we will talk about here today. And in 2010, so 15 years ago already, we had our first fully autonomous system up and running. And frankly, looking at this autonomous system, it was a three-dimensional dynamic system, which is sort of on the coolest part of the spectrum here. Our team on site, when we looked at this and how the robotic nozzles could follow this fire around the room, we got really excited, and we said, well, that's the coolest thing ever. Of course, everyone wants to buy this. And no one did. Absolutely no one was interested at the time. So to put that in perspective, that's 2010, that's 3 years after the introduction of the iPhone. So launching something that's fully autonomous back then was a bit too early, we can certainly say now in perspective. But times have changed, and the technology has caught up. There's been generational changes in the market. So there's a new generation of customers and people looking at this now. And moreover, there's been a huge sort of shift only in recent years with the technology and what people expect. So now we all have our autonomous or automatic vacuum cleaner. I have 2 GPS guided lawnmowers. You can take a ride in a driverless taxi. So autonomous is becoming a very normal thing and something that people expect, which certainly wasn't the case 15 years ago. So sitting here today, we can look back and we can say, well, we certainly started out a little bit maybe too early, but that early start have now given us a 10-year head start. So we started seeing some real interest in these products about, should I say, 5 or 6 years ago. And there's massive interest now, and we're getting lots of attention. And it seems like though we were a bit early, now is our time. So with that, I hand this presentation over to Roger, and I will rejoin at the end of this presentation to answer any of your questions. Roger.
Great. Hello, everyone. Again, thank you for joining. My name is Roger Barrett James. I'm the Executive Vice President of Unifire, and I've been involved with these systems from the very beginning. Been with Unifire since 2005. So I have a long history, and I've been involved in the international sales of these systems, marketing, and I'm also the general counsel for the company. So I'm looking forward to sharing with you. I'll go ahead and share the presentation. Presumably you can all see that, correct? Can you guys see my screen?
Yes.
Great. Okay, so we have quite a bit to cover. What we're talking about really is the smart fire monitor revolution that's happening. As Mattias said, everything's going autonomous these days, and that applies very much to these fixed firefighting robotic nozzle systems. So my aim today is to sort of give you an overview of the state of the art, the different approaches to these systems, how they're working, and hopefully you'll come out of here with seeing something very interesting happening in this market. First of all, what is the problem and why? How do these systems address that? As probably everyone on this call understands, time is the enemy when it comes to fire. Fire grows exponentially when given enough oxygen and fuel, and that is much faster than we normally think. So what I'm going to show you here is testing that we did in the context of the Lashfire project. I want you all to think for a moment how large this fire you think will be after 5 minutes of pre-burn. Hopefully you've envisioned something in your head, and now I'm going to play it at 20 times the speed so you can see what fire growth in reality looks like. That's 5 minutes. Now imagine you're an employee at a recycling plant and a fire like this happens, which they do all the time. And you were told and trained, say, a couple of years ago, what to do in the event of a fire. Oh, you're supposed to go and get that joystick and direct a remote controlled fire monitor. But you don't remember exactly how you did that or where it is. You're going to go running and you're going to call the fire brigade immediately. By the time they get there, the facility is a total loss. And this is happening all the time, especially in the waste and recycling industries. Of course, you have lithium ion batteries that are catching fire all the time and setting off fires. But of course, the problem isn't limited to those. Electronics, high-risk assets, combustible materials at all kinds of facilities are problematic. Again, that fire growth is tremendous. So the whole point is you need to be able to detect that fire and start suppressing it immediately. And this is true. Some of the many applications for these systems are aircraft hangars where you have extremely valuable aircraft, battery farms, and these are going up like crazy as the whole energy market is changing to these. Ro-ro weather decks on passenger ships, military storage, where you have extremely valuable assets and also combustible materials, industrial processes of all kinds in oil and gas, tunnels, and on and on and on. So pretty much any large indoor or outdoor area where you have a risk of fire or high valuable assets. So smart fire monitors are crucially important and making a huge impact because they're able to detect the fire, locate it, and suppress with a high volume of water on that fire right away. So it's truly game-changing technology. Conventional systems take typically much longer and don't apply the same, not nearly the same density of water onto the fire. Sprinklers and deluge systems typically take significantly longer to activate and or give a much lower density of water on the fire and are primarily designed to help slow down that fire until the fire brigade gets there. And by that time, really, you can have tremendous loss of the facilities and potentially even life. So I'll now talk briefly about the different types of reactions, how these systems react. Of course, for many years, we've had remote control systems where an operator can control that from a joystick. But these more automatic and autonomous systems have different approaches. So one is what we call a zone approach, where you have a thermal imaging camera or individual detectors looking at specific portions of a facility, each of which represents a zone. And then the robotic nozzle would aim to suppress that entire zone where the problem is without knowing exactly where the fire is within that zone. You suppress the entire zone. Then you have scanning systems where a fire detector says, hey, there's a fire somewhere. And then there's a thermal imaging camera mounted on the fire monitor. And that fire monitor then starts scanning left and right, up and down until the thermal imaging camera hones in on where that hot spot is. And then the valve is opened and the water is sprayed in that direction. They don't know exactly the three-dimensional area, so they either need to compensate for that, or they might miss the fire. Then you have vector systems where you align the detector that's able to give a vector to the system that could be thermal imaging or advanced flame detectors. And so then the water cannon is able, since they have the same viewing angle, the water cannon can match that vector and aim straight at it and compensate for distance. And then you have the most advanced system, which is a three-dimensional dynamic system where you have two detectors mounted in the corner of a three-dimensional space. Each one is able to give a vector to or the coordinates of that fire. And then the system can determine the exact three-dimensional size and position of that fire, and then very accurately aim the water stream to first surround that fire, to wet the environment, to ensure that it will be contained, and then sweep over it. So intelligent behavior to suppress that fire, knowing exactly where it is. We're seeing three categories of smart fire monitors evolve on the market. I've published an article in Gulf Fire magazine that you may find interesting if you want to learn more sort of specifics about these three different categories of systems that are evolving on the market. But I'll go over them briefly here. One we call a remote operator system, and another we call automatic fire monitors, and then there's autonomous robotic fire suppression systems. So I'll go over these briefly with you. A remote operator system is not truly autonomous or automatic. What it does is you have a fire monitor paired with thermal imaging camera and or flame detector at remote sites around the world. These will be offered by a single supplier that maintains a control center with trained staff. And if a fire is detected, then the operator center is notified. They can pull up the view of what's happening there and see that in thermal imaging and or video camera. And then they can decide and see what's happening and decide whether to intervene and then take remote control if they need to intervene, operating that system, looking through their video monitor to suppress that. So some of the advantages are you've got human oversight, they're trained staff, it's staffed 24 hours a day, and and then they're remote controlling to see where that is. So that's all good. Some of the possible disadvantages or cons here are that, again, it's dependent on a human. It requires a reliable internet connection. If that were to go down, then they're not able to control or see what's going on. And because it requires trained staff to be manning those systems 24 hours a day, that there's cost involved in that, which would have a continuing monthly cost associated with that. Then you have automatic fire monitors, and these are fully automatic, and they are fast reacting, but these are less sophisticated, but still do a good job. And I should say all three of these models are far superior to the old school systems of either manually operated or just remote controlled somewhere on site. These are all intervening much faster. But these systems are fast and fully automatic, and these can be either scanning systems or the zone systems, as I described. They don't require any human intervention. They have automatic shut off after a certain amount of time. So typically they start and deploy for a couple of minutes and then shut off and then reassess and then turn on again if needed. They're relatively simple, and they're some of the cons are they're less precise, less customizable than an autonomous robotic fire suppression system, which I'll get to next. They're limited in their ability to adapt to changing fire conditions. So typically they're not dynamic. They're not continually assessing where the fire is, how it's behaving, and so on. They typically cannot be network together or coordinate activities from one system to another, and have limited remote control capabilities. Typically on site, you have a remote control. Then the third category are autonomous robotic fire suppression systems, or ARFs. And these are the most advanced systems with advanced robotic nozzles that integrate multiple detection technologies, so they can use pretty much any detection technology on the market and even combinations of those. And then robotic targeting, accurate targeting of the fire fully autonomously. And these systems then are tailored to the risk and the environment that they're in. This is not a one solution. These are customizable solutions to meet the specific risks and demands of any particular installation. They're extremely fast to detect and begin suppression, typically in under 15 seconds. They have water or foam on the fire. This is precise, dynamic targeting of the fire. These systems have full three-dimensional dynamic capabilities, but also the zoned system reaction, as I mentioned, also vector-based systems, and combinations of those. So you can have a 3D dynamic system looking at the entire area that needs to be protected. But if there's one or more blind spots to the stereoscopic vision of those detectors, you can supplement those blind spots with an additional detector and have a zoned response if there's a fire in that blind spot. So there's a lot of ways to configure these systems. As I mentioned, they can integrate every detection technology on the market. They're also, because they're dynamic, they're able to know exactly when that fire is out. And once we know right when that fire is out, then we can shut that water off as soon as possible after that fire is suppressed. Typically, after the fire is out, you'll continue suppressing for another 30 seconds, and you can program that amount of time just to ensure that everything is wet and there's no further burning embers underneath or whatever, but then you shut off. So that's going to guarantee you the least amount of water usage, and also the least amount of toxic runoff. These are highly flexible, scalable, customizable. They're also capable of remote commissioning and remote technical support. Some of the cons are that there may be an initial cost that's a little bit higher than an automatic fire monitor system, but there are no ongoing costs because there isn't a remote operators involved in that. So there's no ongoing cost. Um, but these, because they're more complex, right, and are customized, we need to look at every project in a custom way to design a system that's the best match. So all of these technologies I said are making a huge impact on the market at an ever increasing rate because they're so fast. You detect, you locate that fire and suppress it, typically again in seconds, and do that fully automatically or autonomously or with a human operator quickly, and hopefully then get to that fire and put it out before it becomes a large fire that is difficult, if not impossible, to manage. Now I'll turn to the Unifier Flame Ranger autonomous robotic fire suppression system specifically. These are the primary system components. So you have detection technologies, and as I mentioned, that could be anything. Typically, we work with flame detectors and or thermal imaging cameras, and these can be any brand. Um, and and then we have an advanced PLC or electronics that process everything and have the software in it. And then that signals and controls the robotic nozzle. Uh, then we have developed advanced software called our Flame Ranger software, which is responsible for bringing in and processing the signals from those various detection technologies, assigning the type of behavior, whether it's going to be a three-dimensional dynamic system, or a zone system, or a vector system, or a combination of those. So we have lots of different capabilities with that software, and programming different conditions into it and so on and so forth. Then we have a graphical user interface for setting up these complex systems because it is complex. In order to do three-dimensional dynamic systems, you need to know the exact dimensions of the room, where everything is placed, exactly the location of the detectors, and so on, to be able to triangulate that three-dimensional dynamic that three-dimensional system and track it, and then also to be able to aim the robotic nozzle to suppress that no matter where in that three-dimensional space it is. So our AMOLITE graphical user interface allows the simplest possible setup of that entire system and has all kinds of functions for programming in conditional responses to say, for example, only 2 of 3 systems should be able to operate at a maximum at any one time, given the pump limitations or water supply limitations and so on. Then, of course, we have advanced remote control systems so that a human operator can always take control. And I'll turn to that now. So these systems, you can control them from anywhere, like a remote operator uh, model. So we have an app for any iOS or Android device that turns that device into a full functioning remote control so that anyone on the site, given permission, would be able to use their phone to control the system. We also have a fully functioning joystick, virtual joystick for any computer that's done over a browser, so it doesn't require installing any special software. And then we have what we call One Direct, which is a sort of you can point at any spot on the floor plan and have the water cannon aim at that spot. And that's very convenient for ceiling mounted robotic nozzles where left is not left and right is not right and up is not up and down is not down because of the orientation of where you're standing in the room. It's a little bit difficult to control a robotic nozzle that's mounted in the ceiling. So we have that software as well, and the virtual joystick can be operated from literally anywhere in the world, and you would need to make sure, of course, there's a secure VPN connection to do that. And then one very interesting aspect of the Flame Ranger system is we can network these systems so that they're talking to each other and coordinating their behavior. This is particularly interesting in large installations where you have numerous systems together. When they're networked, then these systems can broadcast information to each other and share that information and then engage in coordinated behavior. So if a single system is able to detect a fire, then the system triangulates its three-dimensional size and position in that space. That is broadcast to all of the other systems. And then if whichever other robotic nozzles are within range of suppressing that fire, they can join in. And that's really important for a large installation like battery farms, for example, where you want to make sure that you have multiple robotic nozzles able to cover an event to ensure not only are you suppressing the fire, but you're also cooling and wetting and surrounding the other batteries to prevent that from spreading, and any other large installation of that nature. Now, here's the fun part. I will show you just an example of the system acting. The person you see standing here will light a fire and you'll see how the system reacts. And again, this will be fully autonomous. This particular system's paired with a Robotics thermal imaging camera, and I'll let it speak for itself. So in this video, we had suppression in under 15 seconds, which is typical. Fires out, shortly after it's out, it stops. And just to show the dynamic capabilities, here the man is holding a heat source, and you see the robotic nozzle following that heat source around. So that's what we're talking about. Very, very fast response, very fast detection, and very accurate suppression. Now I'll change topics a little bit just to give a feel for where we see this going. This is the fixed fire monitor market as we understand it from research that we've done. In 2024, it was approximately a $1.4 billion industry, and the projection is up to about a $2.6 billion market by 2033. I don't know how accurate those numbers are, but even if they're close, we see that it is definitely a growing market. And again, as these capabilities are become more and more known in the market, we see these smart fire monitor systems and autonomous robotic fire suppression systems capturing a larger and larger percentage of this total market because of the advantages that they bring. And we're seeing that shift happen in real time every day. The number of inquiries and projects we're working on is increasing very, very quickly. So, we went from conventional, manually operated water cannons to then remote control many years ago, and now they're getting smarter and smarter and shifting to these smart fire monitors and fully autonomous systems where seconds matter, the ability to aim precisely matters, the amount of water used matters, right? The facilities are getting more and more expensive, and the items that are being protected, and having that protection 24 hours a day, even when employees are gone and so forth, is hugely impressive. And our experience is once the customers see and understand these advantages, then it becomes a no-brainer. And we're sure that as these systems have been penetrating and growing in the market, each one is sort of an advertisement for itself. The owners and operators that are using these systems are seeing these advantages firsthand, seeing how they're actually saving their facilities. And every one of those, then, I mean, it's a small world, so experience matters, and the word is spreading throughout the community. Again, as Mattias said, really our sales started in 2018, and then have just been steadily taking off since then. Um, we've delivered well over 300 systems worldwide, and it's growing very quickly now. Now I'll change gears to a very interesting development within Unifier. We have developed software to help us design these systems because, as I mentioned, they're complex. You need to make sure that your detection system is able to detect everything in the protected area. You need to make sure that the robotic nozzle is mounted in a way that it can suppress every bit of the floor plan. You need to make sure that the detectors aren't blocked from view from any objects that might be on the floor, walls or machines or stacks of waste or whatever it is. Um, and to design all of these systems, in the traditional way for everyone in the market, has been, using relatively uh, incapable tools to make these design decisions, right? Using a word processor or something to drop the floor plan on, and then trying to estimate the size of the suppression range and put it all together, which is very time consuming and not very accurate. Sort of ballparking it and you know using it, doing that conservatively, but still there's no guarantees, where now we have the ability in-house to engineer and design these systems using software. So what I will do is go ahead and show you how the software works. This is what it looks like. We call it Flame Ranger System Architect. And you can create a new project, and the system will walk you through the project question by question to help develop then the system. And by the way, the system automatically creates the best fit solution for overlapping systems or just the minimal requirements to reach everything. So you put in here the parameters, the size of the building, which type of robotic nozzle will be, whether those are the default settings or different settings, which type of PLC, whether it's a 3D dynamic system you're trying to develop here, or a zone system, or a combination. Then you select the type of detector, which brings in its parameters, how far it can see, the width, the viewing angles, and so on. Whether these systems are going to be networked or not. So once you go through that question wizard, the system has automatically designed the system. So this is an overlapping system where you get double coverage. Then you can bring in the floor plan here that you're given by your client. So here in this floor plan, you see there's a machine, for example. So I can bring that into the model by adding this as an object, a three-dimensional object. I can just outline the object as I'm doing here. Just outline it, bring that in. Here, finish outlining it. Now give it a height, let's say 5 meters. Then I can assign a color, so we can bring in as many objects as we want into this floor plan. Then you'll see it on the recommended system in the floor plan. And then this is the brilliant part here. We go to, I can rename that machine. And now we go and to the 3D view. And now we see the whole layout in 3 dimensions. And you see the machine there and any other objects we can put in there. So this allows us to see everything and actually, and this is the minimal system here. So you can see that you can see the outline of the suppression, how far that one robotic nozzle in the center can suppress. Then we can go to the detection section, and we can see the layout of the detectors of the dual coverage system. And now in the 3D view, let me show you, I can see what the actual detector sees. So I get a view of exactly what that detector is going to see, and any shadows or blockages. And then I can see the view of the other one too. And where you see these shadows, that's going to be blind to a 3D dimensional system because not both detectors see those spots. But in this particular project, I have two different detectors on the opposite wall, and they see everything. And assuming these are networked, then there are no blind spots. And now I can test it and simulate fires anywhere in this space and get a realistic reaction. Here I see that all of the detectors see that fire, and I see that both robotic nozzles are targeting that in three-dimensional space. I also get all of the system data, right? The parameters and a bill of materials, everything that goes into this project once I have it done. And I even can see the reach of each robotic nozzle based on the height and the flow and the pressure settings. And I can change all of those settings and see how that affects that. And all of that's going to go into the report. You see here as I move the robotic nozzle up and down, it affects the reach. So we can design everything very precisely and know exactly how far that's going to reach, and all of that goes into a report. So now I can create a report once I have everything designed exactly as I want. And this report then, you see it's 67 pages. It goes through all the details, tells you about the density of water achieved, the number of robotic nozzles, the flow, the settings, the pressure and flow settings, the reaction type, 3D dimensional, whether it's zoned or a combination of those. We get the floor layout for the recommended two systems or minimal required, single system can do it. And then those parameters, we see the detection layout. We get the 3D view of how that's going to look. We get the flow and reach requirements. Then we have the exact positions everything will be mounted in, and that can tell the installer exactly where to mount the detectors, exactly where to mount the robotic nozzles. Then we have the network infrastructure, how the whole thing is set up, bill of materials, and then of course all of the data sheets and how the system responds and all of that. So very, very interesting tools, and we continue to develop this, and we suspect that this is sort of the way that systems, not only within Unifier, but we suspect others will be designing systems like that as well. So that's it. Hope you found that interesting, and now certainly we'd be happy to have a discussion and take any questions that you have.
Just turning my camera back on. I know Mattias wanted to come in at the end of the presentation, so I'm going to hand the floor to Mattias before I go to the questions. There are several questions in the chat box. Which
Not
are,
really. No, I'm just here if anyone has anything that I can sort of add it to. So
okay.
carry on, please.
All right, no problems. So, and I think really the software that you've just displayed probably answers the first question, in that the capability of the system is almost infinite in the area of coverage, according to the flow, the pressure, the number of detectors, the number of nozzles that you use, etc. So, what will be the effective area or cover areas ARFSS is the zone-wise needed to install multiple device? And I think really the way you described the software answers that. But I'll let you have the floor just so I don't steal your thunder.
Sure. So we design the systems to ensure full coverage of whatever area the customer needs to protect. And obviously, we want to do that in as an efficient manner as possible. And this software actually helps us do that. We can, of course, manually create these systems in that software as well. But the system is designed to set up sort of the most efficient possible system. We have two different sizes of robotic nozzles. So the larger one at higher flows and higher pressures will reach farther. But then, so essentially, most systems are going to be limited to a radius of a conservative radius of around 35 meters. Certainly, these robotic nozzles are capable of reaching even up to 80 meters if you go up to 5,000 liters a minute at 10 bars. But we plan all of that and want these systems to be as efficient as possible. So you want to use the least amount of water you need to cover everything efficiently. But we can then play with the parameters of the flow and the pressure in order to make sure we're able to cover that entire zone.
Okay. So I think that really answers that question very succinctly. And I think a lot of the questions have probably been answered in the presentation. It says, is it suitable for indoor and outdoor use? The answer is yes, because you've seen it indoors and outdoors. And this is from Celine. But one question is, does it meet explosion proof or electrical area classification required for industrial applications? That's quite an interesting concept.
It is, and we've certainly done our homework on that topic. We currently don't offer ATEX certified versions, but we can. And it's been a chicken and an egg type situation for us as a company for many years because people ask for it. And then, you can't just make one system economical. You can't sell one system. You go through the whole ATEX certification process. So we've sort of been waiting for a project that actually requires it. We've actually found that most projects are able to place the equipment outside of the explosive zone, either by placing them high up on a pole to get out of the explosive zone, or just outside of it and aim into the zone. But if not, then if you do require ATEX certification, it's something we can offer, but with a fairly significant lead time and for more than one system, right? It would need to be 10 systems or whatever, and then we can do it because it's not much modification we need to do to make that happen.
No, fully understand that. Mohammed asks, is the system listed for international firms, UL or FM approvals?
So no, until there really hasn't been a standard to which to test these fully autonomous systems as a whole. And we've been in talks with FM about it. There was a standard, but woefully inadequate. One of the very difficult problems about actually regulating, so of course all of the components have their own certifications, but the system as a whole, it's very difficult, especially for an autonomous robotic fire suppression system like the Flame Ranger, because there's so many different ways that we can detect, so many different ways that we can approach the fire, either through 3D dimensional or zone systems or vector or combinations. To have any system certified, right, you're locked into one off-the-shelf thing that's been certified. We're developing at lightning speed. So far, there are no requirements for these systems to be certified. This is supplemental firefighting equipment, and our customers are buying them because they actually work. So the code requires sprinklers, but the sprinklers aren't effective. So we come in as supplemental equipment that actually does the job.
Well, I can add to that just as a brief comment. Sort of one hurdle when we've been looking at these FM requirements is that usually in this standard they state that you cannot make any changes to the software after you have tested and got this certified, which sort of makes it an impasse because software and the sort of operating systems change all the time. And also these systems, you basically have to tailor them and configure them for each installation individually because the challenges are going to be different. Geometry is going to be different. How you need to combine the things, but also the type of fuel and what the risk actually looks like, and on and on. So you're always, I mean, we start with the problem and then we tailor the solution to the problem. Where a standard wants you to come up with a standard gadget that looks like this, and then that's certified, but that's not the actual application and tool you need. So it's difficult. Let's put it that way.
Yeah, I think that's probably the, as you say, the standard requires something to be fitted, installed, used exactly the same way every time. Otherwise, it's no longer standard. So yeah, not 100% with that one. And we've got two questions that kind of ask the same question. What happens if you get multiple heat sources at once that are at different angles?
That's a great question. And we found out, Mattias might want to speak to this, very early on in our adventure down this road. We saw that when there were two fires, the system didn't know what to do. So it froze up because that hadn't been thought about. So very early on in our development of this system, we realized that you have to be able to address multiple fires simultaneously. So the way our system does that is certainly it's not a problem to detect multiple fires, and we address those then in the order in which they have been detected. So fire one starts, we start suppressing it. Fire two starts. Once this is out, we move directly to fire two. Three starts, four starts. We queue those up, and so we can address multiple fires at the same time.
Yeah, I think that again is always a challenge when you've got trying to see things in multiple locations at once. But as you say, you've overcome that issue.
We figured out real quick you have to, because if that's not designed for, the software says it just freaks out. It says, what?
It's actually a very good and very important question, this one, and one that needs to be raised because these systems are driven by software, which means you have to actually define all possible scenarios that the system could detect. So if you have a system that's programmed to basically spray at the fire, and then you have two fires. So and then the system goes, and it basically locks up. So there needs to be all these variations of scenarios, and all of those has to be programmed into the system as a fallback. So what happens if there's one or two or three or four, and if they start at the same time, or if you suddenly have a massive fire in the area where you sort of expect there to be a small one? All of those scenarios have to be addressed in the software. So back to when Roger were talking about automatic monitors where you have one single detector on one single fire monitor, they're going to have that limitation that basically they can aim at the fire, but only one fire. And that's the limit you have. So that's one of many things that we do differently.
Excellent. A really good questions come up, and there's the challenge of, and this is from Mohammed, the challenge of power failure and to keep the system functioning.
So yes, every system needs to have an uninterruptible power source. So that we say right in all of our materials. These systems don't actually require very much power at all. So a standard UPS can power this for plenty of time. But yes, that needs to be accounted for because you don't want these systems to go down, of course.
Super. We got several asking a very similar question about NFPA application or other standards that enforce or recommend this type of suppression system.
Well, there is an FM standard 1421, and again, we think these standards really need to be discussed and rethought because of all of the things that Mattias was saying and I said earlier. These are complex, and it's really hard even to think about how you can come up with a standard that makes good sense that can accommodate these complexities that we've been discussing. It's actually a lot more complex than we've even led on during this discussion. There's a lot of complexities to think about, and how can you create a standard that can look at all of that? Right now, there isn't one, so we're still in the early days.
Super. And again, by the way, Thompson has asked a really, really good question on the back of when you look at how adaptable this system is it compatible with hydrocarbon gas facilities or designed in agreement with the international standards, e.g. NFPA? So it's almost like you've answered the first question about the NFPA and standards. It's just the hydrocarbon gas facility compatibility.
So Essentially, any environment where a robotic nozzle is appropriate for suppression, these systems can be used. Then it's a question of the detection technology that you use, right? You need the appropriate detector. And again, the advantage of one of the advantages of the system that we offer is that we can pair our system with any detection technology. So long as either water or foam or some other agent is an appropriate suppression method, we can address it.
Okay, we're being prompted. We got 5 minutes left, so I'm going to rattle through the remainder of the questions that I can. And one that was key, that's popped out at me. Obviously, I've been an old firefighter. It's quite interesting. About, is there like an override system that the fire service can utilise when they arrive? So that if it's still flowing, they can turn it off or they can turn it back on. So like a remote control side of it.
That's a great question. The answer is, of course, a human can take control at any time. So yes, there's always a remote control available, a joystick, right? A canvas hardwired joystick that anyone can pick up and take control, regardless of whether the autonomous function's ever kicked in or not. So you can take over control from the autonomous function, or if for some reason the system hasn't detected a fire, you can always pick up a joystick and start suppressing with a remote control. And actually, the fire brigade could even remote control from the local fire brigade if the system were set up that way. That's also a very interesting question that I think is worth answering. Mohammed asked, do the flame detectors have separate controllers? These are actually controlled by our system. So we bring in the signals directly into our PLC that I showed earlier, and we process those signals internally. So perhaps that answers your question. That's part of the complexity of the system, is that we are able to take in signals from all different types of detectors and process that, which makes this truly a very smart system, and probably unlike anything else on the market, where our robotic nozzle system itself is really intelligent with huge compute capacity, and the ability to do all of this intelligent behavior.
So the last one I'm going to ask is, what is the failure percentage you would say? So how does it ever fail to operate?
That's a great question, and I will give a very honest answer. We have not heard of a single system failure from any of the over 300 systems we have worldwide since 2018. Other than there was one incident where there was an extremely bright light source in a facility that was causing flame detectors to think that there was a fire. That was worked out, but that's literally the only failure, and it's really just a false alarm that we've ever heard of. So if there have been any failures, I'm sure we would have heard about it immediately. And we haven't. So it's very good news. And we've done, of course, lots and lots of third-party testing over many, many years, and in-house testing and everything else. And we don't get those failures, fortunately. Knock on wood.
That's brilliant. And I'm touching the table to support you on that one.
Yeah, thank you.
So again, I'm going to start drawing together. So I apologize if I've missed any of the questions that you've asked. If you stick I'm sure Roger or Mattias will stick their emails into the chat group so that you can reach out and make direct contact with them if you need any more support or any more answers. And Holger made a statement at the bottom, and I support that. Basically, it talks about stable door management, really, in that legislation and standards they're not forward thinking, they're catching up as technology and everything changes. Then obviously the standards have to take time, and because of the need for the standards to be so accurate, like in the NFPA, it takes a long time to update them. So we're always playing catch up with the standards. So thanks for that statement. So I'm going to ask Roger and Mattias very quickly if they've got a soundbite they want to leave us with.
I saw someone asked about if there's any dates for training, and yes, we do offer training. So if you really want to get into the details. What we've given you today, Roger has given you today, is a very, very big picture conceptual overview, because diving into technical details would take too much time and would be uninteresting for most people. But I invite you all who's been on this webinar today, if you're interested in actually learning more about our technology, we have an excellent training facility in Sweden where we can invite and manage fairly large group and provide training over several days. And you will be experts in this field.
Super.
Roger.
I
Thank
would
you very much
also
indeed.
invite everyone to unifire.com. There's a lot of information there, and there you can contact us directly and find, brochures. If you go to the documentation page, you'll find Flame Ranger brochures, Flame Ranger manual, and manuals for the monitors, and a lot of other very interesting information. So please visit us there, and feel free also to contact us at any time.
Super.
Again, we're
Super.
we're a small company. It's tight knit. You have direct access to Mattias, our managing director, and to me. So feel free to reach out, and we'll be more than happy to share more information at any time.
That's brilliant. Thank you very much indeed. So allows me to draw the webinar to a close. So firstly, thank you to everybody who's attended. We have great attendance today, and there's been some fantastic questions. So thank you for that. Shows you're engaged and listening, and Roger stimulated your mind, as did Mattias. I'd like to thank Roger and Mattias for being here and presenting what was a really thought-provoking presentation. It's made my mind work, which is always difficult, but it was good. I'd like to thank Unifire AB for being the sponsors today, and Fire Middle East for being the host and allowing me the opportunity to engage with you and learn. And for me, whilst I'm an old firefighter and I like to go inside buildings which are on fire, and Mattias knows that, he teased me about it the other day, this sort of system helps keep my firefighters safe. It helps business continuity, business resilience, and sustainability. If you think about the triple bottom line, the people, the planet, and the profit, when we look at this, it can be used and considered in that way. So we're bang on 2:00 UAE time, so wherever you are in the world. So thank you very much indeed, and I wish you all the best. I wish you safe journeys if you're traveling, and I look forward to seeing you again on the next one. Thank you, everybody.